Every single year, billions of aluminum cans are produced, used, and then recycled. In fact, aluminum is one of the most recycled materials on Earth. The can you're drinking from right now may have been melted down and reborn dozens of times in the past century. The story of how millions of soda cans are recycled so efficiently is not just about saving waste, it's about preserving resources, saving energy, and building a more sustainable world. In this video, we'll take you behind the scenes of the entire aluminum recycling process. From the moment you toss your can into the recycling bin, to the complex sorting facilities, to the gigantic furnaces that melt metal at over 1,200 degrees Fahrenheit, and finally, to the rolling mills that transform recycled aluminum into shiny, brand new soda cans, ready to be filled and sent back to store shelves in just 60 days. This is the incredible process of aluminum can recycling. Before we dive into the recycling journey, let's take a step back and talk about aluminum itself. Why is this metal so widely used for soda cans, and why is it so valuable to recycle? Aluminum is lightweight, durable, resistant to corrosion, and easy to shape. But most importantly, it can be recycled indefinitely without losing quality. That means the soda can you recycle today can be melted down and turned into a new can again and again forever. Unlike plastics, which degrade over time, aluminum retains its strength and purity no matter how many times it's recycled. This makes it a circular material, a true closed loop. That's why aluminum recycling is often held up as one of the best examples of a sustainable industry. Another incredible fact, recycling aluminum saves up to 95% of the energy needed to make new aluminum from raw materials like bauxite ore. Producing virgin aluminum is an extremely energy-intensive process that involves mining, refining, and smelting. By recycling, we dramatically cut down on greenhouse gas emissions and conserve natural resources. So when you toss that soda can into the recycling bin, you're doing a lot more than getting rid of waste. You're actually playing a part in one of the most efficient recycling systems humanity has ever built. Let's follow the journey of a single soda can. Imagine you just finished your drink at home, at school, or at a sports event. If you throw the can into a recycling bin, you've just taken the first step in a much larger process. From there, local waste collection services gather up recyclables from households, businesses, and public spaces. These materials are loaded onto recycling trucks and transported to a facility known as a Materials Recovery Facility, or MRF for short. At first glance, an MRF might look like a giant warehouse full of conveyor belts, machines, and massive sorting equipment. But inside, an incredibly precise system works to separate different types of recyclables: plastics, paper, cardboard, glass, and metals. Now comes one of the most fascinating parts of the process: sorting metals. Soda cans are made from aluminum, but in the recycling stream, there are also steel cans like soup or food containers. So how do facilities tell them apart? This is where clever physics comes in. First, powerful magnets remove ferrous metals like steel. Aluminum, however, is non-magnetic. To catch aluminum, recycling plants use something called an eddy current separator. Here's how it works. A fast rotating magnetic drum creates a changing magnetic field. When aluminum passes through, the field induces tiny electrical currents in the metal, which creates a repelling force. This literally throws the aluminum off the conveyor belt into a separate container, while other materials fall straight down. It's a brilliant system that allows machines to separate thousands of cans every single minute with astonishing accuracy. Once separated, the aluminum cans are compacted into massive blocks called bales, each weighing hundreds of kilograms. These bales are now ready to begin the next stage of their journey, being transformed back into pure aluminum. Bales of cans are transported to specialized recycling plants, where the real transformation begins. First, the cans are fed into shredders, enormous machines that tear the cans into tiny pieces about the size of a fingernail. Why shred them? Smaller pieces are easier to clean, melt, and process. After shredding, the aluminum fragments are put through a cleaning system. This removes paint, coatings, labels, and any remaining liquids or contaminants. One common method is to use a high-temperature furnace that burns off coatings and inks, leaving only clean aluminum scrap behind. At this stage, the aluminum is ready for the heart of the recycling process: melting. Inside huge industrial furnaces, the shredded aluminum is heated to temperatures above 200 degrees Fahrenheit, or about 660 degrees Celsius. At this point, the solid pieces transform into molten aluminum, a glowing, silvery liquid metal. This molten aluminum is carefully tested for purity. Sometimes, recycling plants add small amounts of virgin aluminum or alloying elements like magnesium or manganese to ensure the final product meets strict quality standards. The molten aluminum is then poured into massive molds, forming giant slabs called ingots. Each ingot can weigh several tons and measure several feet in length. These ingots are the foundation of the next step: rolling. The ingots are transported to rolling mills, where they are reheated and passed through a series of powerful rollers. Imagine squeezing dough through a rolling pin, but on a massive industrial scale. With each pass, the aluminum slab gets thinner and longer. After multiple stages of rolling, the metal becomes an incredibly thin sheet, often less than a millimeter thick. This thin aluminum sheet is the perfect material for manufacturing soda cans. The sheets are rolled up into giant coils, each weighing several tons. These coils are then shipped to can manufacturers, where the final transformation happens. At the can manufacturing plant, the aluminum coils are unrolled and fed into high-speed machines. Discs are punched out of the sheet and stretched into the familiar cylindrical shape of a can. Other machines add the top and bottom, apply labels and logos, and prepare the cans for filling. What's amazing is the sheer scale of this operation. Modern can-making lines can produce thousands of cans every minute, all perfectly uniform in size and strength. And here's the most incredible part. From the time you toss your empty soda can into a recycling bin, it can take as little as 60 days for that same aluminum to be back on a store shelf as a brand new can. That's just 2 months to complete the entire recycling loop. Why does all this matter? Let's talk about the bigger picture. Every time aluminum is recycled, we save enormous amounts of energy. To produce 1 ton of new aluminum from raw bauxite ore takes about 14,000 kilowatt hours of electricity. Recycling that same ton requires only around 700 kilowatt hours. That's a savings of more than 90%. This energy savings translates directly into fewer carbon emissions and a lower environmental footprint. Recycling also reduces the need for mining, which can cause deforestation, water pollution, and habitat destruction. In fact, thanks to recycling, nearly 75% of all aluminum ever produced in history is still in use today. Think about that. The soda can you recycle today could contain atoms of aluminum that were first mined over a century ago. Of course, the aluminum recycling process isn't perfect. Contamination, when non-recyclable items are mixed in with recyclables, can lower efficiency. In some regions, not all cans make it into the recycling stream, and many still end up in landfills. But the industry is improving every year. New sorting technologies, better collection systems, and consumer awareness are all driving higher recycling rates. Many beverage companies are also committed to using more recycled content in their cans, which helps close the loop even further. Looking to the future, aluminum recycling may become even more efficient and widespread. With growing global demand for sustainable packaging, the humble soda can could continue to lead the way as a symbol of circular economy and environmental responsibility. If you enjoyed learning about the incredible journey of soda cans and the power of recycling, don't forget to hit that subscribe button. We share more amazing stories about how everyday things are made, recycled, and transformed. Join our community, and let's explore the hidden processes that shape our world together. Subscribe now, and never miss the next incredible process. In a handful of modern recycling factories across the US, broken bottles, shattered windows, and piles of glass waste are getting a brand new life as colorful, durable tiles for homes, offices, and even luxury hotels. In today's video, we're going to take you inside one of these factories and show you exactly how trash becomes treasure. From the moment the glass arrives to the moment the finished tiles are packed and shipped, you'll see every step in the journey. And trust me, it's way more fascinating than you think. Before we jump in, if you love discovering how everyday things are made and how waste can be turned into something amazing, go ahead and hit that subscribe button and turn on the bell. We post fascinating behind-the-scenes stories every week, and you don't want to miss what's coming next. All right, let's head inside the factory. It all starts with mountains of glass waste. Every single day, trucks pull up to the factory loaded with recycling bins, giant bags from construction sites, and crates from municipal collection programs. This isn't just beer bottles and soda jars, it's everything. Old mirrors, cracked windshields, broken tabletops, even glass from demolished buildings. If it's glass, it can be recycled. At the gate, every load is weighed. The weight, the source, and the type of glass are recorded. That way, the factory can track exactly where each batch came from. It's like keeping a paper trail, but for glass. Here's the thing about glass waste, it's never just glass. You've got bottle caps, plastic labels, bits of ceramic, maybe even a stray fork or two. All of that has to go. So the first stop is the sorting line. Workers stand along fast-moving conveyor belts, pulling out big contaminants by hand. Anything that could jam the machines or ruin the tiles. Next, the glass passes through high-tech separators. Air jets blow away lightweight trash like labels and paper. Magnets remove any metal, like jar lids or steel bottle rings. Screens and sifters shake out small stones or dirt. Then comes the washing stage. Imagine a giant industrial dishwasher. Jets of water blast away leftover liquids, sticky soda residue, and fine dust. After this bath, the glass sparkles. Some factories sort glass by color at this point: clear, green, amber, because it makes it easier to control the final tile color. Others keep it all mixed for a more speckled mosaic look. Now the clean glass heads to the crusher. This thing is a beast. Huge spinning hammers smash the glass into small chunks called cullet. If you've ever dropped a glass and seen it break into thousands of tiny pieces, this is the same idea, except controlled and consistent. The pieces are usually between the size of a pea and coarse sand. Why crush it? 2 reasons. 1, smaller pieces melt more evenly later in the kiln. 2, it's easier to mix with other ingredients when it's fine. The finer the glass, the smoother the final tile surface will be. For some designs, they even grind it to a powder so fine it feels like flour. Crushed glass alone can't hold the shape of a tile. It needs a glue to bind it together. This is where binders and additives come in. The cullet goes into massive mixing drums, along with clay or porcelain powder, gives the tile strength and structure. Pigments, or color. Want a bright cobalt blue kitchen backsplash? That's thanks to a pinch of mineral pigment. Fluxing agents. These lower the melting point of glass so the factory can save energy when firing. The recipe is like baking cookies. A little too much of one ingredient and the whole batch turns out wrong. Technicians carefully measure each component to make sure every tile looks and performs exactly the same. Once mixed, the material feels a bit like damp beach sand, gritty but moldable. Here's where the transformation starts to get exciting. The glass mixture is fed into tile presses, huge machines that slam down with tons of pressure, squeezing the mix into perfectly flat, square shapes. These presses can pump out hundreds of tiles per hour. For more artistic or decorative tiles, the mixture is poured into molds instead. Some designs even sprinkle in bigger chunks of colored glass at this stage, so when the tile is fired, you get gorgeous jewel-like specks inside. When they come out of the press or mold, the tiles look, well, kind of dull. They're just pale, chalky shapes. But that's about to change in the kiln. Freshly shaped tiles are still damp from the mixing process. If you put them straight into a hot kiln, they'd crack from the steam pressure. So they go into drying chambers, long, warm tunnels where hot air gently removes the moisture. This can take anywhere from a few hours to overnight, depending on the tile size. By the time they leave, the tiles are completely dry and ready for the big heat. The firing stage is where these lifeless chunks of glass and clay turn into something you'd actually want on your kitchen wall. The tiles are loaded into tunnel kilns, basically giant ovens the length of a city bus. Slowly, they move through zones that get hotter and hotter until the temperature reaches between 1,500 degrees and 2,200 degrees Fahrenheit, about 800 to 200 degrees Celsius. At these temperatures, the glass particles soften and fuse together into a solid mass. Pigments wake up, revealing their final, vibrant colors. Any larger decorative chunks melt just enough to bond with the rest, creating smooth, glassy patterns. The factory controls the firing time and temperature down to the minute. Go too hot, and you lose the color. Too cool, and the tile stays brittle. When the tiles leave the hot zone, they can't just be dumped into room air, they'd shatter from thermal shock. Instead, they pass through an annealing section, where the temperature drops slowly over several hours. This gradual cooling relieves internal stress, making the tiles much stronger. By the end of this stage, they're cool enough to handle, and they look completely different from when they went in. Smooth, colorful, and solid. Some tiles go straight to packaging, but many get extra treatment to make them even more beautiful or practical. Polishing for a glossy, mirror-like finish, texturing for slip-resistant surfaces, perfect for bathroom floors, glazing to add shine, depth, or patterns. The finishing line is where tiles really show their personality. It's also where quality inspectors check for chips, cracks, or color issues. Anything less than perfect gets recycled back into the process. Finally, the good tiles are stacked into cardboard boxes, cushioned to prevent damage, and labeled with size, color, and batch number. The boxes are loaded onto pallets, shrink-wrapped, and rolled onto trucks. Some will head to local home improvement stores, others to high-end designers or export markets. From here, they'll be installed in kitchens, hotel lobbies, swimming pools, anywhere a beautiful, durable tile is needed. It's proof that with the right technology and a little creativity, even broken trash can be turned into something beautiful and lasting. And that's the incredible journey of how broken glass gets a second life as beautiful, durable tiles. If you enjoyed this behind-the-scenes look and want to see more amazing transformations like this, make sure to subscribe and tap the bell icon so you never miss a new video. Thanks for watching, and I'll see you in the next one.
We take scrap material, we melt it down, then we send it through the rolling mill and we make rebar and we make T-post and then we ship it out.
Tell them, hey, mommy has a really good career.
Totally generated over and over again, and we just keep, we're a mini mill, we have some micro mills.
Bridges, buildings, any kind of roads. The new Texas Ranger Stadium all has our rebar.
Family, Steel, Texas, that retired from there. My grandpa retired from there. I have an uncle in Steel, Arizona. It's in the blood. You know, I like it. I love it.
CMC always recognizes hard work.
Every day, mountains of scrap metal are tossed aside. Forgotten relics of old cars, demolished buildings, and decommissioned machines. But what if we told you these discarded metals are being reborn as one of the most essential materials in modern construction?